Why don't we see certain traits in nature? If evolution is so innovative, if it's powerful enough to create this, and this, and this, and this, and this, and whatever this is, then why can't humans grow wings and take to the sky? Or why don't fish have propellers? Why are there no five-legged cats or giraffe-sized chickens? And why do no animals have wheels? And why haven't zebras evolved laser turrets to fight off lions? Today, instead of talking about incredible, mind-blowing traits that evolution has created, like we've done so many times before, we're gonna talk about the limits of evolution's creativity and why certain traits are impossible to evolve. There's a myth in evolution that nature is infinitely creative. It isn't. Probably. By considering the reasons why certain things can't evolve, we can learn a lot about how evolution actually does work. So yes, while these would all be awesome, I don't make the rules, okay? Evolution does. Stupid evolution. I want a tank zebra. We begin in my childhood nightmares. The 1985 film Return to Oz was one of the most terrifying films I ever accidentally flipped the channel to as a young nerd. This unofficial sequel to the 1939 film The Wizard of Oz provided the fodder for more than one nightmare, thanks in large part to these. The Wheelers. Come here, chicken. There is something deeply unnatural about a creature with wheels instead of hands or feet. I mean, both because it's extremely creepy and because it's biologically impossible. The wheeled animal question is a canonical case study when it comes to impossible things in evolution, or forbidden phenotypes. And remember, a phenotype is the observable physical properties of an organism. There are organisms that roll up their entire bodies to enable wheel-like rolling movement, like pangolins, spiders, tumbleweeds, and roly-polies, or whatever you call these things where you're from. Or maybe we could envision an animal rolling around like the mulefa, a fictional species in the fantasy series His Dark Materials, which hooks its feet into round seed pods and uses them as wheels. But acting like a wheel or using a found object as a wheel is not the same as having wheels as body parts. No animal uses a rolling wheel body part to move its body. And some of the reasons why they're pretty obvious. A structure capable of rolling continuously around an axle would be physically separated from the body and therefore impossible to build in a developing animal. This would also make it impossible to deliver nutrients and blood or nerve impulses to the wheeled appendage as well. But there are other less obvious reasons animals don't have wheels, which brings us here. To a Bronze Age foot soldier, the most terrifying sight imaginable would have been enemy chariots rolling onto the battlefield. Manned by a driver and either an archer or javelin thrower, the ability of these horse-drawn wheeled vehicles to move quickly across the field of battle made the chariot the dominant shock and awe weapon of its time from Mesopotamia to the Mediterranean. But by the 6th century AD, the chariot, along with almost every other wheeled form of transportation, had basically disappeared between North Africa and Central Asia. How could such a seemingly dominant technology just vanish? Because wheels had been replaced by camels. Now, this happened for several reasons. The roads originally laid down across the Roman Empire had deteriorated. The skill and craftsmanship required to make efficient wagons and carts had slowly been forgotten. But most simply, in this particular region, camels were just better and more efficient than wheels when it came to carrying stuff. The camel can travel farther with less food and water than a horse or ox. They can cross rivers and rough terrain easier than a wheeled cart. And where a wagon requires a person to tend every 2 animals or so, half a dozen fully loaded camels can be managed by one person. Likewise, Europeans were stunned to find no wheeled vehicles used by the Aztecs, Incas, and other American indigenous cultures, even in places where llamas were used as pack animals. Now, archaeological discoveries show us early American cultures definitely invented wheels of their own, but beyond water wheels for milling or toys, they didn't find wheels all that useful or necessary for their particular terrain and environment. And this is how Chariots and Camels and creepy Wizard of Oz sequels relate to evolution. Biological or cultural adaptations depend on the environment in which they arise. The best solution to a problem depends on the problem. Now, while propellers and spinning blades are an optimal way to move human-made craft through the water, the fins of fish are actually more efficient at providing propulsion in most cases. So there's no fish with propellers. And because we haven't been able to match evolution's aquatic creativity, we don't have boats powered by big tail fins. Likewise, the wheel, as a technology, isn't intrinsically better or more advanced than other ways of moving. The wheel only dominated in certain environments, under certain conditions. And even if animals were capable of growing wheels as body parts, in most environments and terrains, they would probably work worse than feet or hooves. Which brings us to a different kind of terrain altogether: the fitness landscape. Now here, I don't mean fitness like your ability to run a mile or do push-ups. In biology, fitness is essentially a score that represents a trait's ability to survive and reproduce. The wings of birds, bats, and even pterosaurs are all modified structures of the arm, hand, and fingers. They're an example of convergent evolution, where organisms that aren't that closely related evolve similar features or phenotypes. You have to go back pretty far to find the common ancestor between these winged creatures, but the wings of birds, bats, and pterosaurs are all descended from an arm that is built essentially the same as yours or mine. One bone up here, two bones here, lots of little bones here, and long bones here. So theoretically, humans could evolve wings, right? Actually, no. When a trait evolves, every stage of its evolution pretty much has to provide an advantage, or at least not be harmful. Even if the final trait, like humans flying with wings, would be super cool and give us lots of new advantages, we would have to be able to get from this to wings in a way that every step is beneficial. You can't evolve anything that reduces your fitness. A fitness landscape is a way to look at a lot of different variations and how they score versus one another. Each square represents a variation or genetic possibility. And the closer the squares, the more similar two variations are. The further the squares, the more different they are. The fitness of each genetic possibility is represented by its height on the landscape. Now here's the problem. You can only ever move uphill toward higher fitness. There may be a highest peak with the best trait on your landscape, but you can't get there because you'd have to travel into a valley first. Evolution is walking around this landscape blind. It doesn't plan or have foresight, so organisms often get stuck on top of these little hills called local optima. They're as good as they can be without getting worse. The human eye is a perfect example of a local optimum. If the optic nerve and the eye's blood vessels ran behind the eye instead of right through it, we wouldn't have a blind spot in our vision. This is how octopus eyes are built, and it is a much better way to make an eye. But we can't jump all the way to that higher fitness peak, or travel through a valley where we'd make our eyes worse in the meantime. Likewise, if we wanted to have wings like birds, each stage of our evolution from arms to wings would have to provide a benefit. When the first birds were evolving from raptor-like dinosaurs, they already had feathers for attracting mates, so they could use them to glide like flying squirrels. That's a fitness advantage. And each tweak and variation would help them glide farther. More fitness improvements, all the way up to powered flight at the top of a fitness hill. Now, for humans, variations in our hands and arms that gave us a small amount of gliding ability, well, they wouldn't really improve our fitness right away. But having dumb wing hands would have a lot of costs when it came to things like using tools. So even if being able to truly fly would be a huge improvement overall, Those intermediate steps, they can't evolve if they mean moving down the fitness hill. And this is why zebras don't have laser turrets. I mean, zebras would clearly benefit from evolving defensive laser weapons to keep lions away, but they can't because the intermediate steps of evolution have to be helpful or at least not harmful. A laser turret or machine gun or a bazooka is only useful when it's complete. The intermediate functionless laser organ would just be hogging vital nutrients, and that's a fitness loss. And sure, projectile weapons have evolved in other animals, like archerfish that hunt by spitting water, or antlions that use sand as a projectile weapon. But if you're prey, running away might just work well enough, so you're stuck at a local optimum without laser turrets. Of course, I'm not willing to give up my dream of flying so easily. Maybe there's another way humans could grow wings. I mean, why can't we just grow a new set of limbs? You can imagine this strategy working for some bugs, like millipedes. Entire body segments could be duplicated thanks to mutations in genes controlling how the body develops. And poof, you've got a new pair of legs to add to your 48 other pairs. The mutations in a class of body patterning genes called Hox genes have been linked to misshapen feet and hands and skulls, even extra fingers or toes. In very rare cases, humans are even born with extra limbs, like this baby who was born with 3 arms. But almost always these duplicated limbs don't function because the new limb also needs bones and joints and its own muscles and nerves, and each of those duplications would require countless other mutations in other genes. That's beyond unlikely. Evolving wheels instead of feet, or finding a fish with a propeller, or modifying our hands into wings like a bat is difficult enough to be impossible. But at the end of the day, there also has to be a need to evolve. You don't just get something because it's cool. This is perhaps the worst car ever made in the history of driving. The Trobot had a 25 horsepower 2-stroke engine closer to what's in a lawnmower than a car. A plastic body, no fuel door, no rear seat belts, not even a turn signal indicator. Although their design changed little from the late 1950s through 1990 when production ceased, more than 3 million were sold. That's because this was one of the only automobiles available in communist East Germany. Before the fall of the Berlin Wall in 1989, East Germany was a closed economy, meaning there was no competition from other car manufacturers and no pressure to improve this vehicle. For natural selection to happen, an organism has to run into some challenge that impacts its survival, what we call a selection pressure. The East German lawnmower sedan never had selection pressure from other automobiles, forcing it to improve, so it continued to sell well despite being very bad. Sauschlecht, Sauschlecht, Sauschlecht. Apologies to all the Germans out there. Until humans experience a selection pressure for gliding, we won't start to evolve adaptations that lead towards flight. And sometimes selection pressures can be so sudden or different that there is no adaptation for evolution to even act on. The dodo had no adaptations for defending itself because it never encountered humans or other predators. And well, we all know how that ended. But beyond all of these principles of evolutionary biology, one of the biggest limitations we face is physics. How was that? The reason we don't see gigantic land animals like Mr. Longneck here anymore is because of 2 pesky bits of physics. One, gravity. You're probably familiar with that one. Personally, it's how I stay so down to earth. 2, the square cube law. As an organism gets bigger, its volume increases much faster than its surface area. So as something grows and gets more and more volume, any process that depends on the amount of surface that you have will become less and less efficient unless you change your shape to make more surface. This is the reason that big complex organisms like us are multicellular instead of 6-foot-tall single-celled amoeba blobs. That wouldn't provide enough surface area to exchange nutrients and waste and make energy for all of our big blobby volume. So instead, our bodies are made of 37 trillion cells, give or take. It's the only way to have enough surface area for all of this. Gravity and the square cube law combined is why here on Earth, it's unlikely we'd ever get land animals weighing more than 100 tons. It's also the reason if you're ever given the choice of fighting one horse-sized duck or 100 duck-sized horses, you should always pick the fight versus a horse-sized duck, because duck legs would snap like toothpicks under that weight. And the limitation of physics are not just something that animals have to worry about. Calculations of how gravity affects the flow of water in trees estimate the maximum height a tree could ever reach on Earth is 130 meters. And sure enough, the tallest tree we know of is just under 116 meters tall. However, a different physical environment comes with different physical restrictions. Blue whales, the largest animals to ever live on Earth, weigh up to 173 tons because the buoyancy provided by their watery environment counteracts the gravity. Therefore, on different planets with lower gravity or different atmospheric composition, we might be able to see bigger animals. For instance, 300 million years ago, the concentration of oxygen in Earth's atmosphere was much higher than it is today, reaching as high as 30%. And insects, which don't have lungs and circulatory systems like we do, they breathe by gases just diffusing into their bodies. Well, they were able to grow much larger than insects today. Dragonflies the size of birds. No thank you, sir. For all of nature's creativity, a few empty spots remain on the tree of life, where branches seemingly can't grow. What we call impossible phenotypes that, as far as we know, have never arisen in the history of Earth. Like freshwater coral reefs, or birds that give birth to live young, or plant-eating snakes. I mean, there are thousands of species of snakes. You'd think one would take advantage of the food source that all of the other snakes are ignoring and go vegetarian. I mean, snakes' closest relatives, lizards, many of them eat plants. I mean, making the switch from a meat-eating to plant diet worked for pandas. Well, barely. But maybe there's something about how a snake is built that prevents it from getting enough energy from plants. Of course, maybe we also just don't know. For a long time, it was believed that all spiders were carnivorous, until we found one that eats plants. It's difficult to say things are totally impossible. Given more time, evolution may well produce some of the things we've talked about. Imagine if alien evolutionary biologists studied life on Earth 450 million years ago. I mean, flowering plants, flying insects, animals able to walk and breathe on land. These may have seemed like impossible phenotypes back then, but all of them happened. So while there are limits to what evolution can do in single lineages, like humans growing wings or animals with wheels, we don't really know where the boundaries of evolution are as a whole. Like, what about animals with an odd number of limbs? I don't mean 3 limbs like Simone's super cute dog Scraps. A 3-legged dog is just a 4-legged animal that lost a limb due to an accident or medical issue. Or a 5-limbed animal like a starfish. Radial symmetry removes many of the limitations that would prevent odd numbers of limbs. I mean a 3-limbed animal like a dolphin. Think about it. I mean, how many legs does a dolphin or whale have? Their fins have 2 lobes, and their prehistoric ancestors, well, they walked on all 4s, but for all intents and purposes, couldn't we consider a dolphin an animal that evolved to move with 3 limbs? Does that mean that kangaroos and their powerful tails, or monkeys with prehensile tails are, functionally speaking, 5-limbed animals? Are snakes 1-limbed animals? In these cases, although they're rare, there was an evolutionary path that allowed an odd number of limbs or limb-like appendages to arise from even-numbered ancestors. That's a pretty remarkable leap. For all the rules and impossibilities that we've talked about, the things evolution has been able to mold and create are pretty impressive. So instead of looking at what nature hasn't built, maybe we should marvel at all that has been. Stay curious. We're still not gonna grow wings though, sorry. There is one way that you can help our show continue to evolve. You know, get wings or laser turrets maybe. You can support us on Patreon. There's a link down in the description where you can learn more about our community, join these fine people who help us make videos just like this one. Thanks for sticking around, and we'll see you next time. Pew pew. Laser hands. Relate to evolution. I almost said wevolution. So, this unofficial sequel to the 1939 film, the Intermediate Functionus. But the wings of birds and bats and pterosaurs. Never done that before.